Hi guys, welcome to IB Solution channel. Today we're gonna solve 2026 physics, paper 1, I believe it time zone B. Some of you guys have this paper released in IB Docs or Pilot IB, whatever. But those of guys you don't have this paper, and those of guys who want the clear version for this paper, because in IB Docs or Pilot IB, you have like very unclear photos with a bunch of handwriting drawing there. So if you want this clear version, then just go to the IB Solutions Instagram account, and there we have one video for that, and just comment 2026, and then I sent you the link to download. So let's go into the question 1. So it's going to be a long video, right? So, and I take some time and I go slow as much as I can, and I just go through all the details that you have to know about this exam. Okay, firstly, we have an object moves at rest from the rest. So that means our initial speed equals to 0, and the uniform acceleration a over a distance d. Okay, so a is just a, and s, we normally say s, right? So that goes to d, and the time t. T is just t, right? So from this, so we want to know what's a. So from this, we need to use the Subat equation or kinematic equations. So from that one, I should use s equal ut plus half at squared. So instead of s, we have d, and u is 0, so that cancels out. So that's half times at squared. So half is going that way, and t squared is going that way. So a equal 2d over t squared, which in that case c. That's easy one, right? So let's go into the next question. Question 2. The ball is launched with the initial speed of 10 meters per second and angle 30 to horizontal. That means something like that, right? So we have launched from that, and that initial speed is 10 meters per second, and the angle is theta. Angle theta is 30 degrees. Always try to draw the diagram, even if that's a simple one, okay? So what's the instantaneous speed of the ball at the top of its path? So which means that it goes that way, right? So from the top, that one factor we have to know is there's no vertical speed at the top, right? So because the vertical speed, this one, gets smaller and smaller when it goes to the top. So from here, the vertical component of the speed is 0. So we only have the horizontal component of the speed, which is in that case same as that one, right? So that is just 10 cosine 30. So cosine 30 is root 3 over 2. So that is just 5 root 3. So which is about B, 8.7. Okay, so just put in a calculator, then you have that number, 8.7. Right, question 3, we have free body diagram for inclined plane for that. So I'm not going to go through all the details, but I just want to know what's the components along the side of the plane, right? So from that one, I have to reserve the W, which is weight. So I have to go something like that first, and then this to reserve this W, right? So let's say we don't have the angle theta here, but let's say we have the angle theta here, then that's just W sine theta, and this one is W cosine theta. We often say these two, they're the same, right? So normal force and W cosine theta is the same. But if you look at the diagram, then we can clearly see that the friction is smaller than W sine theta, which is component that goes down to the slope, right? So that means our sigma f equals ma, and our sigma f is W sine theta minus friction f equals ma, which is not 0 in this case, right? Which means that we have acceleration for some numbers. We don't know the numbers, but they certainly have, right? That means it's accelerating. Accelerating means that the speed increasing. Right. So from ABCD, the right thing to say about this is the box is sliding down the plane and with increasing speed, which is B. Okay, next question, we have question 4, and also we have free body diagram. The pendulum is hanging with the string here, right? So they said we have to find the moment when the spear is released with angle theta, right? And we want to know what's the magnitude of tension T when it is released. The one thing that I realize is students might find confusing about this one because they try to reserve the tension instead of the weight. Because what is the problem when we try to reserve the tension in here is something like that. So let's say we try to resolve the tension from here to here. And because this is theta, right? So that angle is 90 minus theta. So we can say this component here is t cosine 90 minus theta, or we can actually say that's t sine theta, right? The cosine 90 minus theta is just sine theta. That's what we can say. Also, we can say about this component here is t, let's say cosine theta, or you can say that's t sine 90 minus theta. And from this one, we normally say that that is that. So t cosine theta is mg, or t sine theta sine 90 minus theta is mg. But if you look at the answer, there's nothing in the correct answer in here, right? So that's one problem here. Let's say that we have this one, two, these two is equals to each other's, right? But how about that one? We cannot deal with this one. This is the problem when you try to resolve the tension T here, okay? Because we have this one, that means that we have speed, that we have force, acceleration, and speed. But the point when we release it, there's no speed, which means that there is no acceleration, which means that there is no force, okay? So we shouldn't have any force on it, okay? So that's the problem when you try to do that. So the other way we can actually do that is this. So instead of we resolve the tension T here, we try to reserve the weight mg here. Okay, so this one actually should goes to like that direction along the line with the tension T. Okay, so it goes to that way. Okay, so it goes to that way here. And let's say if that force is equal to tension T, then we can say there is no resultant force, which means that there's no speed. Okay, so when you try to do that, this one is angle theta, so that here is angle theta as well. And that one is the greatest, should be the greatest force. So this component should be our hypotenuse. So it should be actually something like this. Okay, so I actually made it too big. So let's say that we actually should have drawn something like this. Okay. So if I try to get this one here, then that's just the mg cosine theta here. So then we can say that mg cosine theta should be equals to tension T in order to get the sigma f equals to 0. Okay, then we can say that one. And if we try to find, we don't have it, but we know that mg sine 9 minus theta. It's the same as cosine theta, which in that case, D should be the answer. Next, we got question 5. We have two blocks, P and Q, and they try to collide. But there's one thing that we can notice is they collide elastically, right? So what that means? So even if there is, whether it is elastic or inelastic collision, there's one thing that we should be conserved is momentum, okay? So momentum must be conserved in any circumstance, but elastically, that means that the kinetic energy must conserve as well, right? So we have to conserve two things in that case. So let's think about the momentum first, okay? So that one momentum is mass times velocity, which is 2mv. However, we have to choose which path, which direction is positive direction, and which one is opposite direction. Okay, so let's say that from left to right is positive, and from right to left is negative. Okay, so that means our momentum should be positive 2mv. How about q? That momentum q equals to mass times velocity, but we have minus in that case. Okay, so the total momentum in the system has to be 0 because that one plus that one is just 0. Okay, so that one should be 0. So one possibility that if we collide together and the momentum is 0 means that they stop. Okay, when they collide, they instantly stop. Okay, that's one option for that, right? So it can be in some other situations, but it cannot be in that situation because of this one here. Okay, so let's think about the kinetic energy here. In this part, our kinetic energy is just half mv squared, right? Half mv is 2v squared, which means that we have a 2mv squared. How about this one? Our kinetic energy for that part has to be half mv squared. So think about it, it's just like negative v, and if we square them, just that just goes to positive. So I don't need to care about that. So that one is just mv squared, right? So if we add it together, we have 3mv squared, which means that we must have some velocity after the collisions. Okay, so this one cannot be. How about B? P moves to the left and Q stops. P moves to the left and Q stops, but that doesn't make sense, right? if the Q stops, then Q's momentum is 0, but they have some momentum here, right? But we have to have momentum equals to 0 in total, so cannot happen. The P moves to the left and the Q moves to the right. Is it possible? It can be, right? Because in that momentum plus that momentum must be like in opposite direction, which means that one is plus, one is minus. If you add it together, it can be 0, right? And also they have speed from that one and from that one, okay? So it is totally possible. So the answer must be C in that case. Right, question 6. I like this question quite a lot because I have been teaching this stuff to the students, but it doesn't really come to exam quite often. But in this question, we have the things in here. In circular motions, we have the radius r and the road, something like that. And some of the students said that they just don't understand what is going on in here. But here is what is going on. Okay, so we have the circular path here, right? And we have the car goes around. So if the cause goes around the circular motion, then we feels the centripetal force, right? The centripetal force goes to the center, that one here, right? So our centripetal force equal mv squared over r, or m omega squared r, right? But the problem is centripetal force doesn't come alone, right? Centripetal force must need some origin, okay? So what's the origin force for the centripetal force? It's friction between the tire and the road, okay? So the friction goes that way, right? Of course, they have full frictions here, but we only gonna consider the collection of the friction, okay? So that is friction here, and this one should be equals our centripetal force. So our friction equals to mv squared over r. So friction equals centripetal force, okay? What's our frictions is mu times normal force. In that case, just mg, because that's flat surface. We don't have to care about the angle between that, right? So that equals to mv squared over r. So r, the m cancels out, and what they want is the largest v. So let's try to make v equal, okay, that's mu r g, and we got root sign here, which is d, okay? Right, next one, got question 7. So they talk about the accelerations over the distance here, and they stop the distance when it's d equals to 40, right? And they talk about the energy dissipated during the process. When I read the question, I instantly thought that student might find really challenging for that, like some of the students, okay? Because of this energy part and this kinematics part doesn't really come along often, okay? Um, there's 2 hints for that. First hint is when I look at this graph, okay, that's one tip for dealing with the graph is that every time when you look at the graph, 2 things you have to come up with your mind. First thing is slope. What does the slope mean? Second thing is area. I'll say 99% of the graph questions is talking about either slope or area. Okay, 99%. Okay, so when I actually looked at these questions, and I thought that slope or area, but 90% of that is should be area, because if this question is about the slope, it should have like just linear line or like just like something like that. Very simple and easy to read graphs. Okay, but look at this graph. It's something like this. It never say about the slope, okay? This is how I actually know this, because that question is actually about the area, okay? So that's one hint for that. And the second hint for that is when they dealing with the energy, okay? Think about the energy that you know. Should be like kinetic energy, gravitational potential energy, elastic potential energy, something like that, right? But none of that actually talk about the acceleration or distance for that. Because think about the kinetic energy, that's just half mv squared. And how about the gravitational potential energy? That's mgh, which is none of that deal with the acceleration here, okay? So that's the challenging part, because you thought about the energy and then there's nothing connecting with that. But the thing is, I always teach students in IB or like any physics content, energy is very similar to work done. Okay, they are very similar. In fact, the change in energy is work done, or change in work done is energy. Okay, But just don't care about too much about that. So think that energy can be converted into the work. Work can be converted into the energy. Okay, they just equal. Okay, just think about they just equal. Okay, so when they think about the energy and then you cannot find any connection of kinetic energy, gravitational potential, or something like that, think about the work done. Okay, so work done is force times distance or displacement. And just change a little bit. Force is F equals ma times d. Now look at these two factors, acceleration times d, which is here and here. Okay, so this bit is actually talking about the area bit in the graph. Okay, then we have to calculate what's the area under the graph. So that 1 unit area is just 5, and this one is just 1. So 1 unit area actually represents the 5 units squared. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, and 6. Okay, so that's mass times 16 units. Then 1 unit represents the 5 units squared. And what's the mass? They said mass is 1,500. 1,500 times 16 times 5, which is 120 kjoules. Okay, so the answer must be C in that case. Right. Let's move on to the next one. So when you look at this question and look at this, especially this diagram, there's only two possibilities, which is circular motion or rigid body, which is 8.4. But when I say that, it's more likely rigid body, right? So circular motion doesn't come with just one object rolling. And second thing they said, they roll without slipping, which means that they are talking about 8.4, which is rigid body. Okay, right. Let's review what's the conditions they have. They say it travels 5 meters in 2.5 seconds. So the distance it travels is 5 meters, and the time it takes is 2.5. And they said they're completing 5 photons. So what that mean? What that actually try to give us? What's the hint? So every time when they have these terms, 5 tons or even revolution, they actually give information about the angle theta. 1 full ton or 1 full revolutions represent 2 pi radians, right? Because that goes to 1 around, right? So 2 pi radian times, they said, 5. So that, which is this. Okay. Now we just have a list of the evidence, the list of the hints they actually given. But the question said what's R, which is radius of the sphere, radius of the cylinder. Then now it's challenging part to find what's the link between R, D, T, and theta. It's really hard, right? So when you just look at these 4 things, it's almost like impossible to find the link. Okay, so you have to be more flexible, because if I think about it, what they actually try to give is distance and time. We can actually draw the velocity here, because v equals distance over time. That's 5 divided by 2.5, right? So which is 2 meters per second. And how about this? If you try to look at these 2 bits, theta and time t, then you should be able to draw theta equal the angular speed, which is omega equal theta over t. Because, right? Omega, which is angular speed, is measured how fast you go in angle, right? Like this. So that is 10 pi over 2.5. Which in that case, that's 4 pi. And then what's next? Can you now spot what's the link between velocity and the angular velocity? We have v equal omega times r, right? So we have r, v, and omega. So that's 2 equal 4 pi times radius r. So therefore, r equal 1 over 2 pi, which is about 0.16, which is v. Let's go to the next question, question 9. They talked about the spaceship X traveling 0.8 c, and we have spaceship Y going to 0.6 c. So if you draw the diagram simply, space x goes to that direction, which is 0.80c, and spaceship y goes in opposite direction, so they're going towards each other's, which is this. So obviously, this is about 8.5, which is relativity, right? So what equation should we use? Okay, they said which line is correct? From space x, the y approaches 0.38c or 0.2c or something like that. So when you have two different things and two different frames, and then you try to measure the speed, then you should use this equation, which is Lorentz transformation for the speed part. So u prime equal u minus v over 1 minus u times v over c squared, right? So the next thing is you just substitute the numbers. Instead of u have 0.8, and instead of v, you have 0.6c. Okay, so 0.8c minus 0.6c over, we got 1 minus 0.8c times 0.6c over c squared. Then when you calculate that, you have the number of 0.38c, okay? Which is, in that case, that one is correct. And how about the other one? From spaceship y, the x approach is something like that, right? In relativity, it's just everything is relative, okay? They shouldn't have two different numbers for that, okay? So when x see the y approaching that speed here, then y see the x approaching the same number of the speed, but just opposite direction, okay? They must have the same number here, so which is B is the answer. Okay, question 10. The ice is melting inside the container, which has the water temperature 20, and ice completely melts. So let's draw the diagram, something like that. And we have water here, which is 20 degrees, and we have the ice here, and it melts. Okay, so every time when I see this kind of question, I just simply draw the diagram. Okay, and then what's the next? They said which statement about the system during the phase change is correct. Okay, the phase change. So when you're just skimming through the answer, they said about the internal energy, potential energy, kinetic energy, right? So that's all about the energy. So let's think about the internal energy first. Okay, what's the internal energy? Internal energy is kinetic energy plus intermolecular potential energy. So now we focus on the ice part here, like ABC, and this is just the water molecule part. But think about it. The internal energy of the ice molecule increases. So internal energy is just total energy of the system, especially the ice, right? So ice system's total energy, but total energy never changes, right? So it does not change. Second one, potential energy of the ice molecule decreases. Think about the potential energy. So about the intermolecular potential energy, the gas state has the greatest energy and liquid and solid. So from ice one, it goes solid to liquid, right? Which means that the intermolecular potential energy should increase, right? But see, the kinetic energy of the ice increases. Okay, that's pretty obviously because the ice molecule has barely no kinetic energy. Of course, they have the vibrational kinetic energy, but that's way low. But when it transforms into um, the water molecules, right? So they have some speed for that, which means that they have the translation kinetic energy. So that's correct one. Okay, so the C must be the answer in that case. Okay, the last part is the surface temperature of the star that are moving away from the Earth is 6,500. Okay, this Tom moving away actually reminds me, okay, it should be the Doppler effect, right? But there's other numbers are given. So they said what is the color of the peak of the star emission spectrum and which direction it is shifting to observer on Earth. That's what they said. So if you think about when it's moving away, which is 99% of the galaxy does, and this star does as well. And when it moves away from the Earth, we always see the red shift toward that, right? So the direction of the shift must be towards the red, okay? Because that's red shift. But it does not mean the star appears the color of the red, okay? It simply does not connect each other. It's simply like totally different things, okay? That's two different things. But the other ones we have to care about is this number here, okay? Then you should think about the wavelengths of the maximum or the peak times temperature T equal 2.9 times 10 to the negative 3, which is Wing's law, right? So you substitute number 6,500 here, and you should calculate the wavelength here. Then you'll have about 445 nanometers for the wavelength here, okay? Then what's next is, like, you don't know this numbers is blue one or red one, right? So you have to actually go into the formula booklet, which is here, okay? When you go to page 5 and the down part here, and we have electromagnetic spectrum here, right? This wasn't given in the formula booklet the before 2025, but it is given now, okay? So if you see that all the spectrum, we have gamma ray, X-ray, UV light, infrared, microwave, radio waves. But in the middle section, we have the visible light section, okay? In visible light, from red to violet, we have that numbers here, okay? Towards the red, we have 700 nanometers, okay? And towards the violet, we have 400 nanometers. And the number we got was 445 nanometer, which is not obviously the red one, okay? Should be about this here, which is blue, okay? So that is why the color of the star is blue, okay? So B must be the answer for that. Right, next question, we have question 12. They talk about the greenhouse gas. So what's the greenhouse gas, the rules? So they have like in atmosphere, right? So when the incoming radiation goes through the atmosphere, but note that the incoming radiation has barely no infrared in it, right? So they're mostly visible light and UV light. So it goes there and it hits the ground and it stays in the ground, okay? They stay in the ground during the day, right? So the ground gets heated, so the temperature goes up, the energy is stacked, and then at night, okay, at night, so there's no sun there, then the ground has some energy, right? But the energy goes down because it's cold, okay? And outside there is no sun's energy going down, so it's cold. So the energy goes down, right? So the visible light energy spectrum goes down, so which means that the infrared is the next one, okay? So infrared now goes out from the ground, okay? Now the infrared interact with the greenhouse gas in the atmosphere, and that interactions, of course, the resonance, because of the resonance, the vibration kinetic energy increases. So that interaction has some kinetic energy, which is the temperature and the energy part. And it goes all the direction actually, but some of them goes towards the Earth again, so which makes a problem for that, right? So that is the things. So which one is the right one? They said they observed infrared radiation from the surface of the planet. That's the correct one, okay? Because some of students might think they observed the incoming radiation, but that's not correct. But they just has to be observed from the surface, okay? So D must be the correct answer. Next one, we have ideal gas flow things, right? So we have two equal volume A and B filled with the ideal gas and the pressure or something like that. So let's throw it out. So we have A container and B container, they have the equal volume, right? So B. And the pressure for A, the pressure equal 8.1 times 10 to the 6. And the temperature is 18 degrees Celsius. But let's transfer into the Kelvin. So that's 291 Kelvin, something like that. And then the B1, the pressure in B is 5.3 times 10 to the 6, and its temperature is 36 degrees. So that is actually plus 273, and that is 309 Kelvin. So two of them, they said, what's the ratio of the number of gas of atom in A and number of gas of atom in B? Right. So to solve that one, they actually talk about initially they talk about the number of atoms, right? But because they are actually looking for the ratio, it does not matter we actually change it into the moles, okay? It does not matter because it's the ratio, okay? But if they are not mentioned about the ratio, if not, they're not finding about the ratio, if they finding about actual number of atom, we have to find that n, right? But because that's ratio, we can actually talk about the moles. So what's the equation we have to find about is PV equals nRT, or you can literally say PV equals the NKBT. Either way, you can actually use that. Okay, I'll use the upper one, right? So PV equals NRT. So let's rearrange. So N equals to PV over RT. So we can now compare to the N of A and N of B. Okay, so let's think about the N of A equal pressure times volume. So pressure is 8.1 times 10 to the 6 times volumes over the R is just constant and T, which is temperature 291. How about NB? NB equals to the pressure is that times 10 to the 6 and volume, something we don't know, but we know that they are same. And R times 309. What's next? We have to just divide them. This divided by this, and volume cancels out and R cancels out. So you can only just put into the calculator. Then if you put into the calculator, you find a number about 1.62, which is B in that case. Let's move on to the question 14. This is pretty easy one, right? What's the adiabatic process in that diagram, which is A, right? Because if you know, then you know. If you don't know, you just don't know, okay? Because if you think about it, C and D is obviously not the one because D is their pressure is the same, and C, which is their volume is the same, which is an isovolumetric process, and this one is isobaric process, right? And we just have to know what's the A and B. So this curvy line, they represent either isothermal, which is the temperature is the same, or adiabatic process, right? But the problem is the adiabatic process that has steeper line. Okay, if you compare these two curved line, and you just have to find which one is steeper, which is A. That's adiabatic process. Okay, so let's move on to the next one. So again, there's one more of ideal gas, which is N equals to 1. And temperature of the gas is, so initial temperature is 80 degrees Celsius, or you can actually convert into 353 Kelvin, right? And they push with the force, so F equal 500 Newton. And the distance it actually moved is 10 centimeters. So I don't like the centimeter, that's 0.1 meters, right? So they said, what is the final temperature for that? Right. So that one is pretty hard when you actually think about it at first, okay? So what I actually think whenever I face this kind of questions is Q equal delta U plus W, which is first law of thermodynamics, okay? So I find that the students don't often think about the first law of thermodynamics important, but it is very important equation and it actually used quite a lot in exam, okay? So think about it when every time when you have this kind of or other kind of question as well, okay? It's very important question, very important equation, okay? So what's the next? So let's think about this one first. U, delta U, is obviously same as 3 over 2 nRT plus W, which is in that case the work done. But normally we calculate work done as P times delta V. However, we don't know about that, but we do know about force and the distance because our definition of the work done is force times distance, right? So you can actually calculate that one. So force is 500 times distance 0.1, so which is 50 joules, okay? So that is 50 joules. And now let's think about this one. Is 3 over 2 n is just 1, r is just constant, which is 8.31, and times, they say, is delta T. So change in temperature, so that in that first situation, the temperature was 353, right? And we want to know what's the final temperature. So their delta T is final temperature minus initial temperature, which is 353. That's the Q. But I think we actually need more like hints for the Q, right? But we can only assume that because that's isolated system, and we just assume that the piston is pushed pretty hard and pretty fast. Okay, when the process happens pretty fast rate, and if that's insulation between them, it's adiabatic process. Okay, we can assume that, but I think they need more hints for that. But they don't really say about that. But we can only solve when we assume that this process is an adiabatic process, okay? Because only adiabatic process, the Q equals to 0, right? So then this one here, we can now calculate all the numbers, okay? So in that case, our final temperature, if you calculate in the calculator, then you will have final temperature equals about 48 degrees Celsius, okay? So C is the correct one here. Moving to question 16, which is B.5 electricity, right? Next question, we have B.5 electricity, and especially electric circuit. I find students find it really hard. So let's go deep in dive. So we have two situations, and then we had like the identical light bulb. Just think about it as the resistor, okay? So identical resistors, X and Y is in series and Z is in parallel. And then next situation, the Z is burnt out, so we don't have to care about the Z, right? So if you are not familiar with this type of graph, you can always change into like very similar graph, something like this. So instead of a light bulb, you can actually draw these two resistors here, and then Z at the bottom. Okay, it's essentially the same one, right? And then we have ammeter here. Let's say ammeter here, and voltmeter is something like connected here. It's the same one. Okay, so if you are too confused about it, you can always convert into that, and then you try to solve it. Right. So they have the identical resistors, which is RRR. Okay, so let's think about the total resistance in situation A and B. So in that situations, we have these two added together, which is 2R, and that 2R and R is in parallel. So their total resistance has to be 1 over 2R plus 1 over R, which is 3 over 2R. Therefore, our total resistance in that case is 2R over 3, right? So if we have that one, and then we have voltmeter here, let's say, and voltmeter EMF, let's say just is V, and if that first situation, they said this one is just reading is I0 and that one is V0, then we can actually say that using the V equals IR, we can say that the total potential difference, which is EMF, is I0 times resistance, which is 2R over 3. Okay. Right. Let's think about the second situations. So the Z is burnt out, so which means that the only resistance they have is 2R in series, so they makes 2Rs, right? So if you think about it, the EMF does not change its, right? So V equals IR still can available. So V equals to I something, I would say I prime times R. Instead of R, we have 2R, right? And this V must be the same, so I can substitute that one into here. So that's I0 times 2R over 3 equal I prime times 2R. So that 2R cancels out. So therefore, we can say I prime, something that I want is I0 over 1 over 3, right? So that is either A and C, okay? So now let's go into the potential difference part. So let's think about it, okay? If that is V, right? And that V goes this one and here at the same, right? So in this part, whole potential difference is V. Because that's in parallel, that means the Z part has potential difference V, right? And the potential reading was the V was V0, so which means that the EMF is essentially V0 in that case, okay? But the next thing is they said this one actually burnt out, so that cancels out, okay? So that's that. Just think that that does not exist, but that potential difference actually connected into here, this part here, right? That one here. But think about it. I said this part actually gets the same potential difference with the EMF, okay? So the second situation's potential difference reading must be also same as the V, okay, which is essentially V0. So that means the voltmeter reading must be the same, okay? So that means the C must be the correct one. We have SHM situations, and they talk about the kinetic energy. So when they have these ABCD situations and the graph things, the very important thing is when initially, where does it start from? Okay, so they said at t equals 0, the object goes through the equilibrium position, which is x equals to 0, right? So when t equals 0, x equals to 0. So that gives a lot of hints for that. And the kinetic energy is something dashed line, and potential energy is solid line. So which one represents which is that? First thing first, I can erase that one and that one immediately because the energy cannot go to the negative side. Okay, so B and D just cancel out. Only possibility that energy goes to negative value is when you deal with chapter D, which is field, with gravitational field and electric field, that potential energy can go to zero because the definition, okay, because the definition of the gravitational potential energy and electric potential energy can go to zero. But apart from that, we cannot go the energy to zero. Okay, so that two cancels out. So it's either A or C. So let's think about the kinetic energy first. And I often give you a example for simple pendulum. So think about it. The two important point for the pendulum is the maximum point and equilibrium position. So that part is equilibrium position, right? X equals to 0. Think about it. Let's say that's A and B. Which part has a greater speed? Or A or B? It has to be A, right? Because when the pendulum goes to 0, it instantly stops and goes, right? So that means in that point, B must be 0, and A must be the maximum speed, right? For the maximum speed things, so that means that their kinetic energy must also equals to maximum. Okay, so when t equals 0, which is dashed line, the kinetic energy has to be the maximum part. Okay, so which means that the dotted line has to be the maximum. So A must be the correct one in this. Question 18, also that's SHM question, and they said something undamped, so don't think about it right now. So mass equals just 1 kilogram, and it goes through SHM, and its period is 2 seconds, and their total energy equal 72 joules. So they said what's amplitude, which is x0 in that case, right? So that's pretty easy, right? Because we have the total energy equation in the formula booklet, which is half m omega squared times x0 squared. So their total energy is 72. But before we go into the numbers part, let's change a little bit of this equation because we don't know the omega yet. However, we do know the period here. So omega goes to 2 pi over period t, right? So that's squared times x0 squared. So now let's put into all the number part. So total energy is 72 equal half times mass, that's 1 kilogram times 2 pi over period. Period is 2 seconds, so that's squared times x0 squared, amplitude squared. So that cancels out, and so that goes that way. So 144 equal pi squared times x0 squared. So therefore, x0 equal root 144 over pi squared, right? So if you calculate that one, then you'll have about 3.8, which is D. Right, next we have question 19. They said the two wave X and Y sent simultaneously through the Earth with the frequency of the 5 hertz, and they travel through the different material in Earth's crust. So something like this kind of question is pretty weird because it haven't seen on the exam for pretty long time, right? So I mean, like the principle they have, because they kind of like it goes through like different part, which means that we can actually use just like V equals D over T and some like refraction part or something like that, right? However, the situation itself is pretty weird because if you see these kind of things at first, you kind of like don't know how to start. But here is what it is. So from X and Y, they send to the signal to the Earth's inside, right? So that goes through something like that. But we know, like inside of the Earth, they have different material, right? We have the ground and core or something like that. We have different materials, right? So that's, I think, what situation is. The wave X has the wavelengths. So X has wavelengths of 1,000 hundreds, and Y has wavelengths of 660. Okay, the waves are detected 300 kilometers from their source. So which means that they detected here, but they traveled 300 kilometers, something like that. So what's the time interval between the detection of the two waves and which waves detected first? Okay, so but think about it, their frequency is 5. Okay, so their frequency is the same, which is 5 hertz. the first thing first, their velocity equals frequency times wavelength lambda. So 5 times, let's say the x is 1,100, which means that they has 5,500 meters per second for the speed. For y, we got, instead of that, we have 660, which means that 3,300 meters per second. So which one is faster? X is faster. So that means that X must detect it first. And the next thing is, because they traveled here to here, let's say this is like detection point, or maybe because they have to travel same distance here to here, let's say this is detection. Because it traveled 300 kilometers, so and we have the speed here, then we can actually say what's the time, because we have distance equals the velocity times time, which means that time equal distance over velocity, right? So distance in that case is 300 kilometers, so 0, 0, 0, and divided by, we have speed for x, right? So that's the time taken for x to be detected. And how about the y? In the same context, we have 300 kilometer again divided by, the speed is 3,300. And if you calculate two speed and then you find the difference between them is time interval, okay? Then difference should be this one here, okay? You should get 36 in a time difference. All right, next we have question 20, which looks like double slit interference, right? Because you have two of the slit, and their slit separation is 2 millimeter, and the distance between slit and the screen is 1 meter, and the bandwidth about the 12 centimeter. So they talk about what's the wavelength about that. So what's the hint? We have to be able to read this diagram properly. Okay, think about, because that's double slit experiment, that you must use S equal lambda capital D over small d for the equations, right? Then what is about the S? What is about the lambda d and small d and capital D? What is it about, right? So first, easy one is this. So capital D is actually the distance between the slit and the screen, which means that that's 1 meter. So capital D is 1 meter. That's pretty easy one. How about small d? That small d is slit separation, which is this, okay? So that's small d equals 0.02 millimeters. I don't like the millimeters. I convert into the meter, so I put 10 to the negative 3. We want lambda, right? But how about S? The common mistake you can make S is you just take whole 12 centimeter, but that is not the case, right? So S is the things between the two consecutive fringes, right? For example, like this and this, or this and this. Like they often say about the bright fringes, right? Actually, it is correct that you actually measure the bright fringes between the distance between the bright fringes. But if you measure the distance between the dark fringes, it should be the same. Okay, in IB question, it should be. In reality, maybe they're not. But in IB question, in theoretical situation, that it is. Okay, so think about it. We have this black band here, and we have black band here. Okay, they actually measure the distance between these two black bands. But if you think about it, here to here, we can say that's 1s. And here to here, we can say that's 1s. Here to here, here to here, here to here, and here to here. Then how many s's do you have? S, 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 S. So we have 1, 2, 3, 4, 5, 6. Okay, so 6s is 12 centimeter. Okay, that means that s equals to 2 centimeter. I don't like the centimeter, so I put 10 to the negative 2 meters. So s is this number. Then now we can actually calculate the wavelength in this situation. So that's 2 times 10 to the negative 2 meters. So then if you calculate that one, then the lambda should be 4 times 10 to the negative 7, or 400 nanometer. Okay, very simple question, but this kind of question can test the students like what if they have the proper knowledge about the double slit experiment, which is good question. Right, next one is question 21. So when I see that question and the diagram, I kind of immediately know that's 3.4 standing wave, right? Because you have that waves in here and things like that. Okay, and when you read the question, they said this piston can be moved, and then you can kind of like adjust the first harmonic, second harmonic, third harmonic, something like that. And when you see the types, it's one open end and one closed end. That's pretty naughty one, right? Because if you think about two open end or two closed end, that's pretty easy, right? They have first harmonic, second harmonic, third harmonic, and blah, blah, blah. However, if you have one operand, one closed-end, that one is pretty special because there's two things that are pretty special because the way they calculate the wavelength is pretty different from the other two. And second, there is about their harmonic. They don't have second harmonic, fourth harmonic, sixth harmonic. Okay, they only have odd number of harmonic, right? So they should be able to have first harmonic. That's okay, but they don't have second harmonic, right? They can have third harmonic and blah blah blah, right? If you know that fact, actually, you can actually cancel out that second. It cannot be happen. Second cannot be happen. Okay, cannot be. It just simply cannot be happen. Okay, and B and D just cancels out. But they said, firstly, when you look at that, this part here, like this, okay, that is the third harmonic, right? And then when you just shorten it, then you just go like maybe this point here, then you have just only that part here, then that's the first harmonic, okay? So firstly, they have the third harmonic, and then if you move, that is first harmonic, which means that third harmonic and first harmonic, that is C, okay? So this question is like, when you know, then you know question, okay? But when you don't know, it's pretty like naughty one. Next one, we have a single slit experiment, right? So which one is like the correct observations for that? So light goes straight through the slit and form a single dot on the screen. That's incorrect, right? Light can go straight through the single slit, right? When your light goes through it, it should be like, it should bend, right? So it is not correct. The light is bent, okay, that's good, at the slit and form a single band on a screen. That is not correct, right? So if you think about it, it should be something like that. If we have screen here and single slits here, right? Single slit here, and the light goes like that way, right? So light go that way, kind of like wave here, and then it bends, right? It's something like that. It forms like interference between them, and then should look like something like that. We have one band here, which is pretty bright, and the other band something like that, and it gets dimmer and dimmer, right? So it's not a one band. It should be like series of the band, okay? Which is actually B. The light is bent at the slit and form a series of bands on a screen. Okay, that's the correct one. Right, next question, we got question 23. And I think that student might get confused what is actually really about, right? What kind of principle, what kind of theory that we should use, okay? But if you think about it, like really closely, they said in a drone actually make a sound which is constant frequency, okay? So kind of like this frequency here and goes into the mic, right? And then it goes like around the circle. And they said where is the drone's positions, the where the microphone registers the highest frequency. And that sentence gives us a hint, highest frequency. Because frequency should be constant, but why do they have the change of frequency? If if there is a change in frequency in IB question, in wave question, there's always Doppler effect. Okay, that's one fact that you should know. If there is a change in frequency, okay, it's always Doppler effect question, right? So when it goes around, so which part is highest frequency? So if you think about the frequency and Doppler effect situations, and think about the ambulance coming towards you, okay? So when ambulance coming up towards us, then the sound is very loud and annoyed, right? Because of the frequency changes, okay? If we feel annoyed, then the frequency is increased, okay? So the frequency increase when it comes towards us. Think about when does the drone comes towards the mic. For example, it goes to that way, for example, then it actually goes far away from the mic, which means that the frequency should be lower. Okay, between the X and Y point, the frequency actually goes down, right? How about like these two? So from Y to Z, right? It goes actually towards the mic. That's pretty good one, right? So from Y to Z, the frequency increases. However, if you think about, we have the other options between Z and W. So between Z and W, it actually also goes closer to the mic, but it goes like more higher rate than the Y and Z, right? Because it's much closer and it goes higher rate than the Y and Z. So then it has to be the D.